Welcome to RoboPrinter. In the last video, we have covered about the voltage, current and resistance, and along with that we have also did few connection which is series and parallel, and we have understood how the circuit works in series connection, how the LED parallel connection circuit works, and we have measured the current and voltage, all the parameters using multimeter. So this video is going to be very interesting because in this video I am going to explain how the switch things works and what kind of circuits you can make using different kind of switches. So in this video we will be also discussing how many types of switches are there and which type of switch you can use for your home application or for different type of scenario. So let's start the session. Before starting the session, I will say if you are new on this channel, please subscribe the RoboPrinter channel. Okay, so here you can see I am sharing my screen, and what is a switch? A switch is a device which is used to interrupt the flow of current, and we have already discussed in the previous video what is a current. Current is a flow of electron. So a switch, what switch does? A switch will interrupt the flow of current, and it is an electric circuit. So a switch is a device which is used to interrupt the flow of current in an electric circuit. Already we have discussed what is an electric circuit. Electric circuit is a closed conducting path through which current flows. And here in the second line you can see switches are essentially binary devices. They are either on or off. On or off, on means 1 and off means 0. It means switch are actually a binary devices, 1 and 0. And there are many different type of switches, and we will explore in this video all of them. Let's start. Yes. So first here you can see this is a symbol of SPST switch, which is single pole single throw, and you can see here these all three are actually single pole single throw switch. And then we will discuss about the single pole double throw also. Along with that we will also be doing activity. In the previous video I showed all the simulation on Tinkercad platform. Today in this video also I will be showing on Tinkercad. We will be making a different kind of circuits, and this video is going to be very interesting because we will be understanding the basic of the switches, how you can make different combination with the different kind of switches. So first let's do one small circuit. Let me explain the slides in the next one. Yeah, so we'll be also discussing about the double pole single throw and then double pole double throw. But today in this video I'll be showing two activity. First using single pole single throw, and then second one I will show with one single pole double throw. So let's do this activity on Tinkercad first. So we will connect one tactile switch, and this switch is also called reset switch. So we will use this switch and we will glow an LED. So let me quickly open the Tinkercad for explaining this thing. I will just go on Google and I'll search Tinkercad. So guys, Tinkercad is the open simulation software where you can design your circuit diagram and you can see the simulation. So this is the platform. So first I'm going to explain about this push button, which is also called tactile switch, reset switch. Let me take a LED and let me take a resistor also. And in the previous video we have used power supply bench. So let me take power supply. Yes. So with the power supply you can actually vary the voltage. Let's say your circuit needs 9 volt, you can give 9 volt. If your circuit needs 12 volts, so you can give that much voltage, because this is a power supply bench which can give voltage up to 30 volt. You can see here we can give power up to 30 volt from this, and we can give current up to 5 ampere. You can see the ratings are actually given on the power supply. So without wasting time, let's make the circuit diagram already we have seen here. This is the diagram, and you can see the animated image of this one. Whenever the switch is getting pressed, the LED is glowing, because that time only the circuit is getting closed. Otherwise, if the switch is open, the circuit is also open. Means if the switch is not pressed, the circuit is open, because there is no continuity in the circuit. That's why it is called open circuit. Now let's make this diagram. So before making the diagram, as you can see here in the slides, here it is explained properly. So in the tactile switch, in the reset switch, these two pins are actually internally connected. Internally connected means if we will give positive to the bottom line, the upper one will also become positive, because they are internally connected. Same thing on the right hand side. If you see, if I'll give minus to this down leg, upper leg will also become negative, because they are internally connected. Yeah. So we have understood this thing. So in order to glow an LED, we have to give positive to the positive leg of LED, and we have to give negative voltage to negative leg of LED, and your LED will start glowing. So what we will do here, first we will connect 1K resistor to the positive leg of LED, and then this leg I am going to connect to this switch. So I have connected positive leg of LED through a resistor to the push button or reset switch or tactile switch, because this is a switch. When you press the switch, then only it is going to make closed circuit. If the switch is not pressed, then it will be in open state basically. Now this leg I have to connect to power supply positive bench. So because this is positive, so let's change the color. Let's pick red color here. And this is also positive, so let's make it red. Yeah, done. So what here I have done so far, I have connected positive of LED with a resistor, and it is going to the first pin of reset switch, and another leg is actually going to the positive of power supply. Now positive voltage we are going to give to this LED with a button. Whenever I press the button, these both legs are going to short. Whenever I press the button, these both legs will be in contact basically. Now we have to give negative voltage to LED, then only it will glow. So let's connect the negative voltage to the power bench, power supply. Negative is connected because this is negative, so let's select another color. I will choose black. So our circuit is actually completed, just need to verify. So for that I'll just click on start simulation, and let me click here. What you can see, whenever I'm pressing the switch, the LED is glowing, and whenever I'm releasing the switch, we are actually providing 5 volt here, so we can increase the voltage also here. Let's give 6 volt so that LED will glow brighter. So I'm going to press again, and what you can see, LED is glowing. If I release the switch, LED will be in off state. If I press again it will start glowing. If I release again, it will be in off state basically. It will be off. Yeah. So this is done. Now we have understand, if we give positive here, this when we press the switch, this leg will also become positive, because there will be a metal contact inside the button, whenever you press the switch, first leg, I mean right leg and left leg, both are going to be short. Whatever you will provide in the first leg, the second leg will get the same thing if the switch is pressed. Okay. We have seen whatever voltage you will give to this leg, this upper will get the same voltage. Okay, so what I'll do here, I will just disconnect the wire here, and this wire I'm going to connect on top, because I have to prove that whatever voltage you will give either down or up, both are going to receive same. So let's see, is it working? Now again I'm going to press, and what you can see, still it is glowing, because whether you give the supply to the down one or up one, they are going to receive same voltage, either it is negative ground one or it is VCC. VCC means positive one. Okay, so this is done. Now let's move to the slide. Let's go ahead. Now let's use single pole double throw. We have used single pole single throw. Let's use single pole double throw switch, and let's do one more activity, and this activity is actually very fun. Okay, so let me remove this one, and what I will do now, I will take another switch. This time I am going to take slide switch, and using this slide switch I am going to turn on two LED. So let me take one more LED here, and again I will connect a resistor to the positive leg of LED, so that LED will not be fused. Okay, so here the middle one you can see the middle one leg of slide switch is common. Common means if I will give positive to this leg, this right leg and left leg are going to receive same voltage. Whatever voltage I will apply to the common, the both leg, right one and left one, are going to receive same thing. So I am going to apply positive to the common. So I will connect positive from power supply to the slide switch. Then we have to give positive to the first LED. So let's connect right LED. Okay, now let's connect the left one, left LED to the left side of the switch. Yes, so I have connected right leg of the LED to the right side of the slide switch, and left leg of the LED I have connected to the left leg of the slide switch. Now this is not done, so let me connect, this is the negative leg of the LED which is cathode, so I will just connect to the negative, and I will change the color also so that there will be no any confusion. Okay, so we are ready to verify this. So what I'll do, I'll just click on start simulation, and the left LED you can see it is glowing, but right one is not glowing, because if you see here the slide switch is actually toggled towards left side. The slide switch is on the left side. If I will press the switch, then you can see the right side LED started glowing, because the slide switch is actually switched to the right side. So with the slide switch I can just make this flip-flop circuit. Isn't it amazing? You can see. Yeah. So guys, if you're watching this video first time, please like and subscribe Roadner channel, because in this video we are going to learn a lot of things. Now we will see the different types of switches, and later on we will also take a look on various type of potentiometer which is variable resistor. So this video is going to be very fun. So this activity is done. Again, let's go to the slide. So we have used this switch, which you can see here. Now moving on. Yeah, and now this time again this activity is going to be very interesting. We all know the motors, we have played with the motors, and we all know motor can move in two direction, clockwise and anti-clockwise. So why can't we control the motor direction with SPDT switch? So today I'm going to show one activity where you will see how to control motor direction using not one actually, using two SPDT switch. So let's see the diagram only you can see here. Circuit diagram you can see here. In this circuit we are going to use two SPDT switch and we are going to control the motor direction. It means we are going to run the motor in clockwise, as well as we are going to see how it will move in anti-clockwise direction. So let's see. Again, I will open Tinkercad, and here let me do the stop simulation. Let me delete this LED because this time we are going to use motor. Okay, so resistor is also not required. Let me remove this. Yeah, we need one more slide switch. And we need a motor. So let me take DC motor. I will use this motor. Okay, let me place the motor on top. Yeah. So in order to run the motor, in order to move the motor, we have to give positive and negative. If you do the reverse voltage, it is going to move in anti-clockwise direction. If you just connect positive to positive, negative to negative, the motor will move in clockwise direction. But if you change the polarity, polarity means positive and negative, if you change the polarity, it is going to move in anti-clockwise direction. So first thing is, here you can see I'm going to connect the positive of the motor to the slide switch, and here I have connected to the right slide switch and I have connected to the common one. The middle one is common, you can see here. Let me change the color. I will just pick a yellow color, and negative one I am going to connect to the left side of the switch. Again, this is also common. Let me give a color. This color purple. Okay, so what I have done, I have connected positive of the DC motor to the right slide switch common, and the left slide switch I have connected to the negative of the DC motor. Now I will connect terminal 1 to terminal 1, and then let me change the color. Yes, now I'll connect terminal 2 with terminal 2. Again, let's change the color. Yes, what I have done, I have connected terminal 1 to terminal 1. I have connected terminal 2 with terminal 2. Okay, now it's time to give power. So what I will do, I will give positive to terminal A or terminal 1, and then I will give negative to terminal 2. Terminal 2. Yes. So this is negative, I will just make it black. This is positive voltage, I will just select red. Yeah. So we are actually ready with the diagram. We are ready. We are done with the connection. Let me do start simulation and let's see. what you can see here, we are applying 6 volt. Let me increase the voltage. Let me do 12 volt. Yes. Now I'm going to press the switch, and what you can see, the motor is actually started moving in clockwise direction. So this time it is moving in clockwise direction. Let me press this switch, and I will do this, and here what you can see, it is moving in anti-clockwise direction. So now we have both direction. We have achieved both direction, clockwise as well as anti-clockwise. I hope you understand the connection. Again, you can see it is in off state. Again, it started moving in clockwise, and the speed is also showing here. Here you can see 24,786 RPM. So this is very high RPM motor, you can say. Usually we see only 350 RPM, 300 RPM, 250 RPM, but this motor speed is very high, because in the Tinkercad they have given the motor where you can simulate, and depending on the voltage you can actually choose the appropriate one. Okay, we have hobby generator motor also. Let me take this one, because this is the motor which you can you have seen in the robotics. This is also called BO motor. So let me connect this motor. I will just delete this one. This motor also comes in a different speed and torque. Usually we have seen 150 RPM with a torque of 10 centimeter per kg. Okay, now let me do start simulation, and first let's change the color. This is negative black. Okay, again let's see this one. This is 500 RPM, I guess 422 RPM, and it is moving in this direction. Minus means anti-clockwise. Now here clockwise, you can see it's moving in clockwise direction. So done, this activity is also done. Hope you understand how to do the connection, how to achieve the both direction, clockwise and anti-clockwise. So with two SPDT switches you can get both direction. You can run the motor in clockwise as well as anti-clockwise. Now let's go to the slide. Okay, now we are going to discuss about variable resistor. In the real life scenario, we have seen different kind of variable resistor. In fact, in our home there is a potentiometer which is also a kind of variable resistor. Using that we used to control the fan speed. Today also we are going to learn in this video how exactly variable resistor works, and what are the inside things, how it works. So we are going to discuss about that. Here you can see a variable resistor is a resistor of which the electric resistance value can be adjusted. So we can increase the value of the resistance, and we can decrease the resistance. And in the last video we have discussed, if you increase the resistance value, current is going to be decreased. If you decrease the resistance value, current is going to be increased. So it's inversely actually proportional to each other. If you decrease the current, resistance will be increased. If you increase the resistance, current will be decreased. It works like that. Okay. So when a variable resistor is used as a potential divider by using three terminals, it is called a potentiometer. So this is potentiometer, and this is rheostat, and this is digital potentiometer, which we will discuss in our next slide. So when only two terminals are used, it functions as a variable resistance, and it's called a rheostat. So in the rheostat only two terminals will be there. In potentiometer there will be three terminals, which we are going to do. Again we will be doing one activity and we will be understanding in a better way. like how it works and how you can control the motor speed and how you can control the LED brightness with the help of potentiometer. So potentiometer is a kind of variable resistor. Using that variable resistor means here you have an option to control the resistance. You can increase the resistance and you can decrease the resistance. If you increase the resistance, current will be decreased. If you decrease the resistance, current will be increased. So let's use a potentiometer. First, let me show you one more slide. Yes. So we are going to use this potentiometer and I am going to show you one activity. The potentiometer is the most common variable resistor. It functions as a potential divider and is used to generate a voltage signal depending on the position of the potentiometer. This signal can be used for a very wide variety of application including amplifier, gain, control, audio, volume. We have seen in the FM radio these kind of potentiometer used to come by which you can tune the frequency. We have seen that measurement of distance or angles, tuning of circuits and much more. When variable resistors are used to tune or calibrate a circuit or application, trimmer potentiometer or tripods are used. These are mostly small potentiometer mounted on circuit board which can be adjusted using screwdriver. Like we used to this kind of potentiometer, and if you want to vary you need a screwdriver of course to increase the resistivity, to decrease the resistivity. And here you can see this is a symbol of potentiometer which we will also take a look in the circuit diagram actually. Now let's make the circuit and let's understand this. So first I am going to show you one circuit diagram through which I will be showing how to control LED brightness using potentiometer. So first let me delete all of this thing. Yeah. Let me take potentiometer here. I have the potentiometer ready. Yes. So again here you can see wiper and then terminal 1, terminal 2. I will take one LED first. I will show the LED, like how to control the brightness of the LED. Then I will be showing how to control the motor speed, because we have seen in our home we used to control the fan speed with the potentiometer regulator. So that things also will take a look. Okay. So this wiper I have to connect to the positive of the LED. I will change the color. Okay. And this terminal 2 I am going to make negative and terminal 1 I am going to make positive, red, and this I will select black, and then negative of LED I will just directly connect to the power supply, or we can connect here also because this is eventually it is also going to negative, so I can connect here also. Okay, let me start simulation. What you can see, the LED is glowing, and also just observe the voltage here. Let me show you the voltage. So currently we are applying 12 volt. Let me decrease the voltage because this voltage is too much for LED. So we will just apply 9 volt. Let me give 9 volt here. We will apply 9 volt only. Okay. So here you can see the current is 7 milliampere and the voltage I am applying 9 volt and LED is glowing. Let me vary the value of this potentiometer. So I am going to touch the wiper, and here you can see, if you observe here in the current, you can see it is actually decreasing. I am increasing this and the current is actually decreasing, because here what I am doing, I am actually increasing the resistance of the variable resistor, which is also called potentiometer. So I am increasing the resistance, and what if you observe the current value is actually decreasing very fast. See, 36 microampere. I have actually turned this wiper at max resistance, and that time the current is coming only 36 microampere, and that current is not enough to glow this LED. Let me decrease the resistance. So here you can see from here it started glowing, but still it is very dim, and as soon as I'll do this again, you can see it started glowing again, and you can see the brightness till here. So if I am actually applying 7 milliampere, then only you can see the LED glowing things. Otherwise, if it is less than 7 milliampere, it is glowing but it's not visible, right? You can see here. Even it is glowing at this rate also 655 microampere, but it's almost negligible. Almost it's not visible here. Only it is glowing when we are applying 7 milliampere. That's it. So let's take the motor also. Let's see how we can increase and decrease the motor speed. So let me take you the motor. The motor I can get from here. Again, let's take this motor only. We have seen the RPM of this motor was very high. No worry, let's take the same motor. Connection will be same. Whatever we have done for a LED, we have to do the same thing for this. But for this, we don't need resistors. Let me connect positive of the motor to the wiper part. A potentiometer and terminal, and this is negative, I will just connect here because this is also going to be negative. Okay. Now let me do start simulation again. You can see the RPM, just observe the RPM of this motor. This time the RPM is 17,847. Let me start increasing the resistance. If I will start increasing the resistance, the RPM will be keep on decreasing. Let me show. What you can see, this time the RPM is 75 bar. Now 37, 32, 20, 19, 10 RPM, 9 RPM, 8 RPM, 6 RPM, and here 0 RPM. So this is the potentiometer, and the value of this potentiometer is 250 kilo ohm. We can also vary this thing. If you want to change the value of this potentiometer, we can also change. Let me take 10 kilo ampere, 10 kilo ohm. So this time I have taken 10 kilo ohm resistance, 10 kilo ohm potentiometer, and if I will increase the resistance, here also you can see the RPM is decreasing. So this is 10 kilo ohm potentiometer, 10 kilo ohm variable resistor. So with the variable resistor, we can change the motor speed, we can vary the speed, and same thing we have seen in our home as a form of regulator. Now again, let's move to the slide. Hope you like this activity. So if you like this one, please like this video, and if you are new on this channel, please subscribe to RoboNerd channel. Let me take you to the slides. Potentiometer we have discussed. So this potentiometer you can see in the volume controller, and in the earlier days, if you have seen in the radio for tuning the frequency, it was actually coming. Now second thing is rheostat. This is also a kind of variable resistor. which probably you have seen in your physics lab. We were using in the physics lab actually. Rheostats are very similar in construction to potentiometer, but are not used as a potential divider, because in this there are two terminals only. In this potentiometer we have seen there are three terminals, but in rheostat there are two terminals instead of three. One connection is made at one end of the resistive element, the other at the wiper of the variable resistor. We have seen in the Tinkercad there was a wiper in the middle, and others two leg we used to make it positive and negative. So here you can see one connection is made at the end of resistive element and the other at the wiper of the variable resistor, by which you will be varying the value of resistance. In the past, rheostats were used as a power control devices in series with the load, such as light bulb. Nowadays, rheostats are not used as power control anymore, because this is a inefficient method to do. Nowadays, there are many digital electronic switches are actually coming, and there are digital variable resistors are coming, which we are using in electronic circuits. So this is the symbol of rheostat chip, you can see, and this is how it looks. In some electronic component you can see this type of also. In the physics lab we have seen this kind of rheostat. Moving on, let me show you the digital variable resistor, which are actually nowadays coming on the microcontroller boards. So a digital variable resistor is a type of resistor where you can change the resistance. Is not performed by the mechanical movement. We have seen for varying the potentiometer resistance, we were changing the resistance using our hand, right? Manually we were changing the value of the resistance. But here the resistance will be actually changed automatically without any physical contact. They can change the resistance in discrete steps and are often controlled by digital protocols such as I2C or by simple up-down signal. So digital resistor is basically used to not, like, if you don't want physical connection, if you don't want to turn on, turn off manually, if you don't want to control the speed, the brightness of the LED manually, what you can do, you can actually connect a digital resistor, and you need program to do that, because here you have to provide signal, and once you provide the signal, it is going to increase the resistance and it is going to decrease the resistance automatically. So without any physical contact, your resistance will be varying, and with the help of that, you can build some automation things. You can build some automation type of application. Let's say you want to control your LED lights, LED bulb in your home. So what you can do, you can connect digital resistor, and you can use some microcontroller like Arduino. You can program Arduino such a way, just you need to give a signal to this digital resistor, and whenever the signal comes to this resistor, it is going to control the resistance, and depending on the resistance, the LED bulb brightness is going to be increased or decreased. It's totally dependent on the digital resistor, and it's also dependent on the signal. Like in the program, if you are writing, if I will write digital light analog 255, then you have to glow the LED at brighter, and if you want to just write 127 in the program, then if you want, LED will glow at half brightness. So that type of automation actually you can do with the help of digital resistor. So I hope you understand in this video how to use digital resistor. So digital resistor does not need any manual interference. You just need to give a signal, and it is going to increase and decrease resistance. So hope you like this video, guys. In the future video, we will also take a look of different type of circuits, and we will also learn about transistor, diode, capacitors. We'll be making a different kind of fun activity, and we will learn all the electronics depth concept in a better way. So if you like this video, please like and subscribe to our RobotNet channel.